my talk is called Rebuilding the Plane While It's Still Flying, and I know that subtitles on talk names are out of fashion, so I didn't give this one a subtitle, but if I had, it would have been even more insufferably long than it already is. It would have been Rebuilding the Plane While It's Still Flying, large-scale, zero-downtime migrations without fear, but obviously that wouldn't have fit on the slide, so anyway. I'm Tyler. I have been a professional software developer for more than a decade, which is kind of weird to say. I've spent most of my time doing soft real-time and distributed systems in various forms. I got started writing Elixir in 2019 when I was working on a massive multiplayer game server for a flight simulator called X-Plane. And I kind of fell in love with Elixir, like many of you, and didn't want to do anything else since then. Today, I work at a company called Felt. We say we're the best way to work with maps together. It's been called the Figma of maps, and we'll see a little bit of what the product looks like here in a minute. Before we get started, if you would like to follow along on your own device, you can grab the slides either scanning the QR code or going to my website, tylerayoung.com. There are too many Tyler Youngs in the world. Or you can find it on Twitter or Mastodon, Tyler A. Young. All right, so let's talk about migrations. First, a migration, when we talk about migration, we're talking about moving your system or some part of your system from one version of a thing to another. So maybe that's architectural, maybe that's the structure of your database, maybe it's the actual data in your database, whatever. And this is triggered by all kinds of things. It might be adding a new feature, fixing bugs, maybe just a changing understanding of your problem domain. And you know, if you've been in software long enough, you know, like the one constant is change. As Titus Winters, one of the co-authors of software engineering at Google, says, software engineering is programming integrated over time. That's integrated in like a calculus sense. So what he's getting at here is like, if you have a script that you're going to run today and throw away tomorrow, like that's programming. And it is comparatively easier to get a system to work today and do what you want than it is to build something that's going to be maintainable and extensible and malleable for the next 5 years or 10 years or 20 years. Out of curiosity, how many people in the room have worked on systems that are like older than 10 years? Okay, good number. How about 15? 20? Oh man. Okay, has anybody worked on something older than 30 years? Oh wow, okay, that's awesome. So and it's cool working on those systems because it really puts into perspective like the moaning that people do about like legacy code, because you know, you kind of gain this appreciation that like, oh, that's actually like the code that pays the bills, that pays the mortgage, that has you know, sustained the company all this time. That's great. So when we think about migrations, there are a few different types. The first is the most common. It's the thing if you've done Active Record or Ecto or any of a number of other systems, you are familiar with it. A schema migration. This is like adding a column, adding a table, removing a table, that sort of thing. You're changing the structure of the database, but not the actual contents of it, not the rows, not the data. Which brings us to data migrations, changing the contents. So what this looks like is, you know, maybe last week we added a column to the database. This week we're running a backfill. Maybe we're calling into some third-party API to get the contents of that new column for each row, or calculating whatever it might be. Code migrations are kind of funny because for the most part, we don't think about changing code as being like a migration. My absolute favorite example of this is years ago, there was a security vulnerability discovered in the hash map implementation that Google used. And when I heard that, it was like, what? Because you don't normally think about like a CVE associated with a data structure. But the vulnerability was that the hashing algorithm used to look up the values associated with the key was insecure. And so an attacker could craft the key, in this case like a username, and if they did it in just the right way, they could get somebody else's data out of the map. And I don't know what the scale of Google's code base was at the time. Today it's like 2 billion lines, and they've got 15,000 changes merging to main every day. And so it was not a situation where they could just kind of flip a switch and change all the usages all across the code base. They would have never gotten through the sea of merge conflicts that they introduced. And so instead what they had to do is introduce the new secure data structure, add a new linter rule that prevented any new instances of the old and busted data structure, and then over a period of weeks or months or years, slowly replace all of the uses of the old stuff with the new one. And then the final type of migration, most commonly seen in service-oriented or microservices architectures is like swapping out a whole system. And you might think about no longer talking to the auth v1 API, and instead we're going to talk to auth v2. In this talk, we're going to mostly focus on data and code migrations. There will be some schema stuff kind of in the backdrop. And if you're like me, you hear about this stuff and you're like, come on, we're moving from one version of a thing to another. Like, how hard could this really be? Like, why are we spending time on this? And to this I say, you're right. Migrations are not that hard, unless they're going to be hard to undo. And you can easily see how this would be the case with like a data migration. Maybe we're backfilling some data in 25% of the rows in your table. If you screw that up, it can be very difficult to tell which rows you changed and which ones were pre-existing. Migrations are not hard unless they can't be done atomically. If the system has to kind of persist over a period of time where the migration is going on, things are kind of shakier. And the other side of that is they're not hard unless they need to be done without downtime. Downtime is kind of a nice Band-Aid over not being able to make it atomic, right? Because if you can take the system down and do a long migration over a period of hours and then bring the system back up, well, from the perspective of the outside world, that change was atomic. And that makes it, that's a simplifying assumption. And finally, migrations are not hard unless other feature development needs to continue apace while the migration's going on. This, you can easily imagine if you're migrating your auth service, you can't just stop and be like, we're not fixing any more bugs on auth v1 while we're working on v2. Like, no, you got to fix bugs there, and you got to change you got to carry those changes forward. Same with new features. And so again, you're kind of building on shifting ground. And there's not really a way around that sometimes. But for all of these reasons, I think migrations, at least by me, prior to actually dealing with the stuff, they were overlooked and underestimated as a challenge in engineering. Today, I think, some of the big migrations that I've worked on, especially the one we're going to talk about here, maybe some of the most significant challenges of my career, which is pretty cool. After all, it's one migration, Michael. How long could it take? 10 minutes? All right, I've got one more piece of housekeeping before we get to my favorite part of the talk, which is story time. And that is how we run migrations at Felt. This is not unique to us, but it's also not like ubiquitous across the Elixir ecosystem, and so it's worth covering because it kind of affects how we did things. So we do blue-green deploys. When we merge something to main, our continuous delivery service running on render picks up the change and starts putting together the new server. And our schema migrations, our changes to the structure of the database, those run before the new server boots. So the new server always exists in a world where its migrations have run. One funny consequence of this is that they run while the previous version of the server is still up. And so you can't have a change that both stops using a column or a table and deletes it in the same commit. Otherwise, the service that is still up will say, I was depending on that, and now everything fails. Following the schema migrations, we boot the server, and then data migrations get run asynchronously and manually, sometime after. The consequence of that, of course, being that the new version of your server has to be compatible with the database both before the data migration and during the data migration and after. Okay, story time. In the beginning, we had this product called Felt, and you could make maps. You could add some text. You could draw on it. You could add a pin. We've got a little pin at the Marriott. You could add emoji and lines and polygons and points. But we wanted more. We wanted to be able to add more context, show more of the geography, show sort of the data, the stuff that was important for people doing actual GIS analysis. And so in this map, I've added wildfires and wilderness areas and intact forest landscapes and riverine flood risks. And you get a much better sense of the geography of Florida. And it also just looks pretty. So from the data model perspective, here's what that looks like. So we had a map, and we had these curated layers that our amazing GIS team had put together. And we needed a way to reference them. Because all of this is editable, a user can change the names of all of those items in the legend. They can change the style. They can really customize these layers, and obviously we can't have them changing the canonical version of those curated layers. So we needed this layer of indirection between them, and kind of creative as the day went, we called that layer of indirection the map layer. You got a map, you got a layer, you smush them together, it's a map layer, right? Yeah, map layer held a reference to a curated layer and provided the styles and the legend and stuff. And this was cool, but inevitably the question came, how do I create my own layers? And now our curated layers, it turns out, they were kind of a science project. Our GIS team, whatever transformations they did on the data that they got, they might have compiled a bunch of different data sources, run it through all these GIS programs that I do not understand, and at the end they produced some tiles. Tiles are the little bitmaps that you load in on a web map to provide the background, right? And their process was not necessarily something we could just hand to users. There wasn't a single process. And so when we supported user uploads, those had to be very well-defined and very linear. So we eventually got to a point where you could drag a file in and it could produce some uploads. This in black is a half marathon route that I ran near my home, and I've added some of our curated layers beneath it to kind of provide more context. In this case, we have two kinds of layers. We have a user layer, which does not support all of the features of a curated layer, again, because it was running through a different process. And we've got curated layers. And so our map layer there in the middle can now reference either a user layer or a curated layer. And we got to this point and we said, it's not ideal that we have these two kinds of layers, but we can live with it. But over time, our users said, I would like to do some of the things that your curated layers do. And we said, we can't do that yet. It's on the roadmap. So the dream was to have a single unified abstraction. And now, of course, if you had asked our product team, the dream was something like providing maximally powerful tools to our users, but we're software engineers. The dream was a single unified abstraction. And so you kind of sit with this problem for a little bit, and you come to the conclusion that things are going to have to get worse before they can get better. Because we've got these two types of layers, they're mutually incompatible, they have features that each of them can't support, and so we're going to need a third layer type. But this is going to be the one true layer. One layer to rule them all, and in the darkness, never mind. Insert the obligatory XKCD about standards proliferating. So we had a couple of hard requirements for this migration. The first was no downtime. At this point, we had launched into our public beta. We had a bunch of attention, and we didn't want to kind of make users question whether we were a serious business by having a bunch of downtime while we did this migration. The second hard requirement, also number one, is no breaking past user data. If downtime looks bad, telling people, your old map, it doesn't work for reasons, that looks quite a bit worse. So how do we get from this world where we have two types of layers to a world where we have three types of layers and back down to one? And I have to admit, at this step, I did not have like a complete roadmap in my head. We knew where we were at, and we knew the destination, and we knew a couple guideposts along the way, but it was definitely going to be a process of learning as we went. So the first step that we took, we paid off some old tech debt. There were cases where we knew in the database things were inconsistent. A field was null where it shouldn't have been null, or it said status success and had no data, or it said status error and it did have data. And, we wanted to similarly clean up the data model to the extent that you can simplify it and have like a more solid place to start from. That's a good thing. As Kent Beck, one of the co-signers of the Agile Manifesto, said, to paraphrase, if a change is going to be hard, first make it easy, and then do the easy change. I wouldn't say we ever got to a place where this change was going to be easy, but we got it easier, right? So following that, we put in place the new abstraction, the new glorious future layer. And it lived alongside the old ones. You had to opt into a feature flag to see it. And when you opted into that feature flag, Your old stuff was probably broken. Anything you had uploaded before didn't work. But that was okay because, only the developers who were actively working on this would opt into the feature, and they could, get their job done. And it was in the course of doing that that we realized that the front end was very tightly coupled to the old data structures, to the point that the front end would kind of send us a map, and we would just dump that wholesale into an Ecto change set to modify a layer. If you wanted to rename it, if you wanted to change the legend items, if you wanted to change the style. And we didn't want to be fighting a war on two fronts and trying to rewrite both the front end and the back end at the same time. And so the back end team, we decided to lie. We put in place this compatibility shim that would present the new layers as though they were the old layers, the old structure, to the front end. And the front end could send us messages in the format of the old layers. And we would look at the ID and we would say either this is a new layer, okay, we're going to do this translation, or it's an old layer and we'll pass it through unchanged. And now with this compatibility shim in place, this was like Operation Unbreak the app, because at this point you could opt into the feature flag and you could still use your old layers. At this point, we actually started turning on the feature flag for our internal users. Everybody at the company was using this. They use Felt every day for their own work, and so we quickly heard about bugs, right? As we opt them all into this, to the extent that there were issues. Following that, we could uncouple the front end from the database schema. We could start sending more specific messages like, please change the title instead of here's a map. Just go apply it to the database. Change the title, change the style as separate messages. And at this point, things were stable. We could ship it to users, and at least we weren't creating new tech debt, right? All of new user layers got uploaded as the new layer type. But of course, we didn't really want to have 3 types of layers around for all times. We wanted to go back down to 1 layer. And so we needed to migrate all of the old user data to the new format. And so there are a couple questions that we wanted to have answers to before we tried to do this. The first, what happens if a user is editing their layer that was in the old structure in the moment that the migration happens for that layer? And in our case, because we were able to do the migration of individual layers atomically, even though the whole migration process is running asynchronously, over a period of hours, individual layers were migrated in a single repo.transaction. And so what would happen is if a user loaded a page, they've got the old layer, they're changing the title or whatever, the migration happens in the background. Because the migration is atomic, when their message comes in to change the title or whatever, they have no idea. And because we kept the IDs the same across the old layer to the new layer, the UUID just, we maintained it, the changes will get routed to the right place. The second question is, what if we need to roll back? What if we get 2 weeks out from this migration and we say, oh my gosh, there's this issue that we discovered. We can't correct it. We need to just undo it and rethink the whole thing. In this case, because each of the new layers held a foreign key into the old table, first of all, we didn't hard delete the layers from the old table. We soft deleted them. And then the new layer held a foreign key to the old layer. So in the worst case, we could have unsoft deleted all of the old layers, soft deleted the new layers, and been back in a state where we were at least back to before the migration. And so the day of the big migration, we back up the database, we run the migration, and we wait. And the funny thing about doing these migrations is that the way you know things were successful is that nobody notices that anything changed. And so you wait, and a couple weeks later, you say, okay, nobody's complained. Now we can actually delete the old code, we can delete the old tables, and we're living in the glorious future. I'm still waiting on my flying car, but we're getting there. All right, so with the time remaining, I'd like to talk about some of the things that we learned going through this process and kind of some of the practices we put in place as a team that I think made us successful. The first is that feature flags are your friend. Being able to opt in just the developers working on the feature to the new and possibly broken version of the new feature was great. It meant we could continue shipping code to main, not have to deal with long-lived feature branches, and all of the merge conflicts that occurred. And likewise, as fixes were needed to the old data structures, we didn't have to reintegrate those in some painful process. Everybody's just living on main. This also let us opt in just our employees to the new version of the feature and kind of suss out bugs there before shipping it to all users. This library, Fun with Flags, is free, open source, and for our purposes, it gives us everything that we would need from like a launch Darkly or something, which is quite expensive. Next, use excellent migrations. This is a credo check. You can stick it in your CI and it will fail. Hopefully it'll fail your build anytime it detects something in your schema migration that is going to potentially lock the database. For instance, maybe you weren't aware that changing a column type was going to have to rewrite your whole table. This has saved me a number of times. And my advice here is to deeply understand the reason that a rule exists. You can go, the Excellent Migrations documentation has a really good explanation for all of the things that it'll catch. Deeply understand why that rule exists before you ignore it. And then when you do ignore it, because in some cases it'll actually be okay to do so, de-risk that by adding a comment explaining why in this particular case it was okay. Maybe you say, in production there's only 100 rows in this table, so rewriting it is not a big deal. Because 6 months from now, inevitably, there's going to be somebody who's writing a new migration, and they're going to say, oh, this is kind of like that thing that Tyler did 6 months ago. I'm gonna copy and paste that. Don't let them copy and paste, ignoring the rule on a table with 1 million rows. Next, lean on safe Ecto migrations. David, thank you for this blog series. It taught me so much, and it has so much wisdom, things that I would never have thought of until they bit me and I spent weeks debugging it. This was like a total jumpstart on my understanding of migrations. I proposed a talk where I just sat here for 35 minutes and read this to you all, but it got rejected, and so instead I have to do this. My advice is whenever a new pattern for a migration is introduced into your code base, have a reference back to safe Ecto migrations to explain why this is actually a good idea, because if you don't have that reference, there's probably edge cases that you're not considering that you've missed. Next, take small incremental steps. I don't know how many of you are PC gamers, but when I play a PC game, I'm mashing the quick save button every 30 seconds, maybe every 5 seconds. It's like I don't want to lose that progress. To me, trunk-based development is like mashing the autosave button all the time, and so you don't have to know every step along the way. If I were having to plan out like every movement of my hands on the steering wheel of my car in advance before hitting the road, like I couldn't make it to the grocery store. But in fact, like I can drive across the country because I know my destination and I can kind of adjust. You adjust in real time, right? My advice here is anytime you have a PR, have a test plan that states like, this is the state of the world before my change, and this is what the state of the world is going to be after. And sometimes it's really clean. It's like, this column is null for all values in the table, and afterward it's going to have real data. And sometimes it's messier, and it's like, there's going to be these 83 values that are still null, and that's okay because of these reasons, and we're going to address it in the future. I found that when I was working in an environment where we were doing long-lived branches, I didn't have these kind of save points, and things were just kind of always a little messier in my mind. Yeah, it's worth doing to really solidify that as you go. Next, practice like you play. For our team, building the habit of doing zero-downtime migrations before it mattered, before we had sizable customer base and a sizable database, it built up institutional knowledge that we couldn't have gained otherwise. It absolutely slows down development in the short term, and you can feel kind of silly being like, we're going to be really rigorous about this migration even though it's only touching 1,000 rows. But yeah, it builds skills that you can't acquire elsewhere. And doing this for a long period of time, we were able to bring people on the team up to speed who only committed Elixir changes once or twice a month, and we could explain to them and build that team knowledge about why this is important and how we do it, and these are the patterns and the tools to help. As Brian Merrick another co-signer of the Agile Manifesto, paraphrases this book, Communities of Practice. He says, you know something if you have experience using it. And I think of, reading books and reading guides as like a map. And it's very, very good to have a map before you start, but it's also not a substitute for actually visiting the terrain. And finally, there is no substitute for production data. If you've done these migrations, you inevitably hit a case where it's like, this value is null. It should have never been null, or this is slow on the production database size, but it's not slow on development size. By experiencing the pain of this, we were forced to kind of come up with a process for taking the production data and getting it into a dev environment and actually testing against that. You might need a process, you might need to anonymize it, you might need to sample it, whatever it is. Having some facsimile of what it looks like in prod will save you so much pain, because failure to do this in the best case means that you get to make multiple attempts at your one migration. In one case, we ran a single migration 4 times because we shipped it to prod and hit an issue, 30 seconds in, and then we shipped a fix and hit an issue 2 minutes in, and shipped a fix, right, 4 times. Of course, the worst case is that your migration does run and it's just wrong. Yeah, being able to check it against prod or a facsimile of prod is very valuable, and it's kind of a pain to maybe get that set up, but it's absolutely worth doing. And finally, because I feel like people might have words with me in the parking lot if I have a whole talk without any code samples, I wanted to share this micro framework we put together for doing backfills. This is based on David Bernheisel's batch and deterministic data recipe. It's a very straightforward implementation of that pattern, but we found it useful because we would very often be like copying and pasting this template into a new migration and kind of tweaking some things. And every time as a PR reviewer, you're kind of staring at it and going, is this the same as the thing, or is it different in like some subtle way? And I got to compare. So I'm just going to show what this looks like to use. We've got use data migration. That's the little micro framework, and that provides a behavior with a few pieces to tweak. So first is the base query. Here we say, from the users table, give me just the user IDs of all the users where their onboarding step is null. And that gets kind of modulated by the config down below. It says we're going to do a batch size of 100, so only grab 100 user IDs at a time. If you've got 1 million users, you don't want to try to fit all that in memory. And then there's this throttle time as well. This case says 1 second. That's kind of excessive. We usually do like 100 milliseconds. But the idea there is between working on a batch, we're going to just pause the migration, just chill, and let the rest of the app actually use the database. We don't want to be hammering it constantly and potentially denying service to real users. So this little framework grabs 100 users at a time and passes them into our migrate function. Migrate gets a list of results. Each of those is just a map with an ID. We pull out that user ID and we send it to our context to actually do the migration. And as I say, the implementation of this is not that interesting. Read David's post. There's a link here. If you go to my blog, it's the second item. The first item on the blog is these slides. Second is this little micro framework. You can grab the code there. Okay, that's all I have to share. Thank you for your attention. I don't know if we have time for questions. Okay, cool. All right. Thanks.